Welcome back everyone to Learning by Teaching. Today we're in dynamics and we're going to solve problem 12.221. It says, two boats leave the pier P at the same time and travel in the direction shown. If VA is equal to 40 feet per second and VV is equal to 30 feet per second, determine the velocity of boat A relative to boat B. How long after leaving the pier will the boats be 1,500 feet apart? Alright, so what we have in here is that we have two boats and they're leaving this pier that is basically is going to be our original point for our XY coordinates. And what we see in here is that our boat V is leaving at 30 feet per second and it has a direction of 45 degrees, and we have our boat A leaving at 90 minus 30, that will give me a total of 60 degrees, okay? And the magnitude is 40 feet per second. So what we need in order to solve this problem is that we're going to utilize the relative velocity equation, where we know that the velocity of A is equal to the velocity of B plus the relative velocity of A with respect to B, okay? And what we need to do is find this relative velocity of A with respect to B, okay? So if we start, our velocity of A is going to be defined as, well, let's first utilize this angle that is from the x-axis should be equal to 60 degrees, okay? So if we utilize that, we will see that our x component or our I component for velocity of A is going to be the magnitude, which is 40 multiplied by the cosine of this 60 degrees, okay? And this is our x component. Then we will have our y component, which is going to be the magnitude multiplied by the sine of 60 degrees, okay? This is in our y component. So we know the velocity of A. We also know the velocity of B. The velocity of B is really similar, just different magnitude and different direction. So we will have the magnitude is going to be 30 and cosine of 45 degrees for our x component. And then for our y component, we will have the magnitude, which is 30 multiplied by the sine of this angle, okay? And this is in the y component or j component. Okay, so now we know VA, VV, so all we need to do is solve for the relative velocity of A with respect to B. And what we have is that we will end up having the velocity of A minus the velocity of B, okay? And if we plug our values in, we will have 40 cosine of 60. So I'm going to make this a big bracket, minus 30 cosine of 45 in the I direction. Then we'll have plus, then another big bracket of 40 multiplied by the sine of 60 minus 30 multiplied by the sine of 45 degrees. And this should be in our y component, okay? So we're going to plug in these values into the calculator, and we will realize that we will get that our velocity of A relative to B is going to be equal to negative 1.21 in the x component, and then we'll have plus 13.43 in the y component if we round it up, okay? So now we have our velocity in x and y coordinates. We can also find the velocity of A relative to V as magnitude and direction. So if we do that, its magnitude is going to be the square root of both components squared. So negative 1.21 squared plus 13.43 squared, okay? If we plug this into our calculator, we will get 13.48, and the units are in feet per second. Okay, so let's not forget that also our velocity unit is feet per second. All right, so now we have the magnitude. So we found the magnitude of our velocity. What we can do is find the direction. So I'm going to assign theta to be the direction of these this vector, and we're going to have that we're going to do the inverse tangent. Well, tangent is the opposite, 13.43 over the adjacent, which is negative 1.21. And if we plug this into our calculator, we will realize that we'll get 84.8 degrees. Okay, so that's the direction of this velocity. So let's put that in. This is our direction, and we're done with the first question. And the first question was determine the velocity of bow A relative to bow B, right? The second question is how long after leaving the pier will the boats be 1,500 feet apart? So in order to solve this part of the problem, what we need to do is just to recall ourselves one of the simple relationships between time, position, and velocity. Well, velocity is equal to the change in position divided by the change in time. Okay, so if we solve for our change in time, so basically how much time will take us, it will be equal to the change in position divided by our velocity. So our time, or our change in time, is going to be equal to, well, how much was the position that we want to find? 1,500 feet apart, meaning that we'll have 1,500 feet on top divided by our velocity. Well, our magnitude of this velocity is 13.48, so you got 13.48. This is in feet per second, and if we plug this into our calculator, this will give me a total of 111.3 seconds if we round it up into only one decimal place. Okay, so we found our time, we found our velocity, so we're good. If you guys liked the video, please push the like button, subscribe, and I'll see you guys in the next one.